I don't know, my eyes have been kind of itchy. I don't know why. It's not like, I don't know. Is the allergy related? Usually allergies are in like the fall, aren't they? I guess it's anytime the season changes. But I'm trying not to itch my eyeballs because it's not a good thing to do. That's how you mess up your eyesight. I think I did that a lot when I was a kid, when I was younger. Now the price I pay is I'm supposed to wear glasses, but I don't. Because I don't have insurance, so I don't want to pay it out of pocket. And not to get political or anything, but here in America, it's not free to go and get glasses. But anyway, yeah, what's today? Today's Tuesday, so continuing with this halftone shader that we were working on last stream. I don't know, I guess I'm not much of a yapper. I mean, I am if somebody's talking to me, but I just can't talk to myself. I gotta get straight into things. So yeah, today we're continuing the, oh, that's simple. No links or anything, it just tells you straight up pretty much what the title is. Stream title. Let me jump over to this here. I don't really remember where we left off last stream, but we were kind of going through this article here. I think we stopped somewhere up here in the article, and we link it. I think it was about here where we made this dot grid thing. And if you're interested in that, it's currently on the GitHub, so to get there, you go here. Or you can refer to the last stream. And it's somewhere inside of this, like, components thingy here. So that was kind of like building up towards the overall halftone effect, or like look. So if we were to continue with this article, they kind of talk about other things you can do with that like dot pattern. You can create different shapes. I'm kind of gonna skip over that. I mean, it's interesting, but I kind of just want to go straight to the halftone part, which is down here. So yeah, let's start here. This halftone effect, let's see if there's a good example of it on the wiki. Oh, it always does that. There we go. So it's made up of these, the way that it works is that you have 3 or more, 4, however many, I guess they're plates. I didn't really do my research here, but it's comprised of 4 plates, and typically in printing you use this CMYK color model for color printing. So this is, you know, something that's been around for a while. And here's a good example of it. You've got 4 different plates here. You can see that you've got your cyan plate, your that's the first, that's C. Magenta, which is this red color. Yellow is of course yellow, and then K is the key plate, which is the black that you see. And you, I guess you kind of like press these against the paper with different these plates. You give them like different angles, and you can control the angle. Um, but they add up to some look. So if you have bigger blue dots, you know, and this is something that you're going to be looking at. So this is kind of like, you know, stamped onto this plate, if you will, or onto this paper, and you're going to be looking at it from a distance. So, you know, if it's majority red, or if this dot, like let's say it's magenta, and your dots are very big, the most of the color that's going to come through is that magenta, but it'll be mixed with some amount of yellow and some amount of blue and some amount of black. So you add up these plates to give you kind of different colors. And typically, I don't know if this is how it is typically. That's kind of the opposite of what I just said, but you can control these radius of these circles like by looking at the actual, in our case, it's going to be the actual texture. I don't know if that's something you can do in like physical printing, but here's a good example here. So they've got 4 and then the black plate, or 3 colors, so there is no black plate on this one. But it adds up to be this bottom right image here. And it looks like maybe you can have different size dots, but you can see like where the dots are big, or there's a lot of red here. It's very red in the final output. There's no blue up in the sky, so they've only got blue up here. But you can kind of get the idea. And that's what we're going to emulate in the shader. But we'll build up to it. And this is the, let's see. What do they talk about here? Like, why is this image here? Yeah, so this CMYK thing, it's typically in your shader, your colors are RGB. So you have to convert to CMYK if you're going to do this process to get this cyan, magenta, and yellow colors. And then they're mixed, you know, they're mixed or whatever to give you different shades and stuff. Yeah, RGB is an additive color model. The CMYK is subtractive. So you start at white, and then I guess you're kind of pulling colors from white. Think about RGB is additive, that, you know, if all your color channels are at their maximum, you get a color of white. Instead, you're going to start at maximum, and you're going to kind of like subtract, you know, yellow or magenta or cyan or black. Black is like subtracting from the overall color. And you'll see that in the shader code. Let's see if they talk about that here. Yeah, it's a subtractive model, reduces the amount of light reflected from a... That's kind of hard to imagine, I guess because we're so like used to RGB colors. But you know, typically you start with like your paper's white, so you're already at maximum RGB. So the only choice you have is to remove color. Let's see. Yeah, let's just get into it. So right now, here's what we have at the moment. Where's our... Just bring me back to localhost. Yeah. So here's our scene. And I've already gone through and set it up here, so we don't have to do all that boilerplate stuff. But all it has is just this GLTF model that's coming from this load abalone thing. So this is an abalone shell or something like that. That's what the model is called. So we've got the shell in the scene, and then all I've done is just applied a color to the background of the scene right here. And it looks a little bit better. Like when we see the end result, I think having a background with some color is gonna look better than having a black background. So if you don't set this, it just defaults to a black background. Oh. Like that. But I wanted a color that was, this one is, I don't know, can we pass in cyan here? Yeah, we can. So I wanted something that was close to cyan, which this one is. And right now we are just kind of outputting the, we're just sampling the texture. So this is kind of like a render pass, and then you send that into a render target, and you're using that target like you're getting it out. Where is it? Right here. So you do a pass of the scene, you render to a target or a texture, and then you've got a texture here, which this has a texture. Or it can be used in TSL at least. So if we jump over to the effect, all we're doing right now is just sampling the texture. If you don't pass anything as this final argument, it's the UV. It defaults to the screen UV. So there is a difference too between this UV, which both of these will come from the TSL import. So these two are two different things. The screen UV is, you know, it's the UV of the screen. So this is 0 over here, 0, 0, 1, 0, 1, 1, and 0, 1 here. The UV is actually the UV of the like face. So if you had like a box or whatever, you know, and you're texturing a box or something, every face of that box is going to have its own UV. And that's how you get access to it, is through UV here. But we're doing a post-processing effect, which is going to be applied to the whole screen like texture. So that's what we need, is a screen UV. In our case, these are going to be the same because of how we're using this shader. But if you were to apply this shader to like a material or something, this UV would be different than the screen UV, because UV in that case is particular to that mesh or that material or whatever. And your UVs are inside of your geometry. But our geometry is just this rectangle here, or the screen. So it's the screen UV. And we'll need those eventually, but I'll import them as we need them. So this stream is just kind of be like yeah, if you're interested in like the CMYK stuff, they've got a little bit of a section here about how it works. But in this stream, I'm just gonna kind of translate this code here. Is it this one? Yeah, this into TSL. It's pretty easy to follow. But I'll explain it as I do it. In the main like code, like the entry point of whatever is right here. And you can kind of see, I'll make this bigger here, the effect of this. This is the output here. So this is the original scene. It's kind of similar to what we have currently, but they're using, you know, different model and different lighting and stuff. But you can control the pixel size. Let's enable it again. Pixel size, so you can see all those dots coming through, and they're different size dots depending on the underlying like texture. This is just the maximum radius of the dot, so it can get no larger than 0.5 here. And you can control the angle of these too. So they have the angles hard-coded right here. The cyan dots are offset by like 15 degrees. And this is the magenta offset, the yellow offset, and so on. There's not a whole lot of yellow in here, but you can kind of see it every now and then. Yeah, like right here. They don't give you control to like rotate these grids, but you can. Like you can pass these in as uniforms into the shader, and we'll do that as well. That's a pretty easy thing. But we'll probably hard code it in the beginning, and then like all these different like constants out here can be converted to uniforms pretty easily. Let's see. Yeah, so this code is above right here, and we'll just start to convert it probably top to bottom. Right, so let me do this here on the other monitor. Okay. So, TSL is cool in that these function things you can just assign to variables because they're just nodes. So you can have a function node inside of a function node. So let's create a grid UV function. This will take some UV and some angle. Angle will be in radians. Maybe we'll just call it radians. And these you must pass in for now. So UV, that's going to be a node type vector 2. So that's your X and your Y. That's your typical UV. This will convert it into a grid UV. And the way that it does that is that it multiplies by the screen size, which is the resolution here, rotates that screen, and then depending on how big you want your dots, it will divide by the pixel size. So what does that look like? You've got your screen here. This goes from 0 to 1 in the UV. In the UV like space, I guess you could call it. But multiplying it by the screen size, now it will go, let's call it S for screen size, from 0 to S. And this is the width, the screen width, and then the screen height. Here, these could be different, but they don't have to be. And then when you rotate it, you're rotating it around 0, 0. So, can I rotate it? I guess it'll rotate around its center. But if we make a copy of this, and then we'll place it on top, and then can we change the color? Yeah. Oh, I want to keep it held. How do I reselect? Yeah, so we'll rotate it, something like that. And it's not perfect, but now we've got, you know, rotated grid. And then when we divide by the pixel size, usually your pixel size is 1. So if you want to just rotate the UV, then just set your pixel size to 1. But our dots are bigger than 1 unit, or bigger than 1 pixel, right? So what we do is we cut up this space into the pixel size. Maybe that's like pixel size of 8 or whatever. So it'll be, you know, chopped up like this along the X and along the Y. And that will give you what they're calling the grid UV. And that's easy to implement in the code here. Yeah, so this will be like this. And what we're returning here, let's see, this will be radians is float or number. So this type floater number, it is found inside the TSL like source code, but they don't export it. But it's a really simple type. It should be like TSL float or GPU float or something like that. But it's node of float or like a JavaScript number. This node you have to bring in from here. Otherwise it thinks it's like a DOM node or something. And let's default this to 0, so no rotation. This will default to screen UV. In that rotation, we can actually bring in the rotate function from TSL. And we're rotating the UV multiplied by the screen size. So if you wanted this to be like even more pure, I guess, then you would take this as a parameter as well. But I think this should be like, we're always going to do this based on the screen size. So I don't even know if I want to pass in UV here, because it's kind of assumed that you are talking about the UV of the screen. And that'll simplify it like this. You take your screen UV, multiply it by the screen size, so that's this step here. And then you're taking out, or you're dividing it, you're chopping it up by the pixel size. So pixel size will be an argument here. And typically when I found that when I'm writing these functions, I like to pass in like the required parameters first as your first argument. Required is this texture node, and then the options here is like object that you pass in as a second argument. And we'll do options like this. The pixel size is an option. Let's call this size for now. That's a float or number. Well, I guess we'll just say number. Well, no, when we divide over here, when you do .div, like this, .div accepts float or number, I believe. So we'll do float or number. And then we'll do a partial of the options, meaning you don't have to pass anything in. We can destructure this immediately, so we'll get the size out. If the size isn't passed in, let's just default to 8, I guess. So what are we rotating by? The radians. And then this thing is just saying that we're not using it yet. Yeah, so now we got the grid UV that we can pass in, which is used in these two functions here, toGrid UV and toGrid UV. So what I want to do instead of passing in the UV here is pass in the grid UV here. And the way that this will work, so you got your grid UV, and that's going to be this here. After you have, let me clean this up a bit. I don't have a, do I have delete? Oh, I do. Yeah, so your grid UV is something like this. Where's my color? Okay, go away. Let's just look at the first row. This is your like grid UV here. But you want to get the center point. And you do that with this get cell center. So I guess they're calling each of these squares like a cell. Now your grid UV, so this number will range between not 0 to 1, but doing the floor here, so I'm trying to think how to explain this. So your grid UV will range between 0 to the resolution divided by the pixel size. If you pass 1 in here, you know, UV ranges from 0 to 1, multiply it by the resolution, that's going to be 800. Or not, like a resolution of 800. Now you're going from 0 to resolution. Dividing it by the pixel size, you're going from 0 to resolution over the pixel size. And let's pretend that we didn't rotate at all. So you've got a number that goes from 0 to resolution over pixel size. Now you need to floor that number because that will bring it to the closest like integer. You know, passing anything in here will just get rid of, well, it'll round it down to the nearest integer. And then adding this 0.5 will now move you into, you know, that number plus 0.5. So if your number was, like if your UV, let's say, was like 532.45 or something, you'd floor it. Now you're at 532. Then you add 0.5. And now you're at 532.5, which is, you know, somewhere in here, but it's going to be halfway into that cell. And that's both on the X and the Y. So that's going to get your cell center. Once you have your cell center, then remember this is rotated some amount. You got your cell center. Now you need to bring it back into, you need to unrotate it and then convert it back into your normal U0 to 1 range. And you do that by kind of doing the opposite of what you did here. So you take your cell center, you unrotate it, that's your minus your radians here, and then you multiply it by this pixel size. That will give you back to 0 to resolution. And then you divide out the resolution, which will get you back from 0 to resolution back to 0 to 1. And then you can use that cell center here. They're getting the UV here. They're using that as input into this texture. So texture 2D here, well, its second argument always wants a number from 0 to 1. So you know that in the end, you want a number here that ranges from 0 to 1. And that's kind of what you're getting out here. But we can do cell center. You can also do this as a function. Oops. Move my mouse. Yeah, so this will take a grid UV. That's going to be a node of vector 2. I just remembered one thing. So I think it's a good idea to, well, I always think it's a good idea to have explicit return types, but especially here because it feels a little bit different than your normal JavaScript, but we know that this function halftone function, we want it to return a vec2. Oh, not here. I want it here. And then, is that happy about that? Yeah. Oh, I see what it did. And why did it? That's weird. Grid UV is not used. Rotate. What happened? I had this. Okay, and then it broke. What I want to do is just put node vec2 here. Okay, that's what I wanted. What is it unhappy about? Oh, I need to pass in the angle. Okay. So what is this? The cell center is function that. Know that this is going to be a node. Vec2. This is a node. We're going to return a vector2 as well. So we got the grid UV. We take the floor of it, so we can do grid floor add 0.5. Okay, and then we need to rotate that. And we're rotating it by radians. Did I have a good way to do this? I don't remember. Let me look at my notes. I think I had an elegant way to do this. Okay, I see. So these are kind of like local functions. So from a user perspective, you kind of want this here when you call it in the actual code. Here, you kind of want them to be able to use, like, pass in just normal JavaScript stuff, like size, or let's do angle. Or I don't know if it's angle or radians, but you want to be able to pass in like math.py here. Not have to have them convert it into a float, like a node or whatever. So at the top level, here, you can pass in the angle. Angle is float or number. And then inside of this function, we'll convert it into a float. And then when we use these, we know that the angle is going to be a float. So we don't have to worry about this being a float. Here, we can just say it's always going to be a node. Or we don't have to worry about the number case, this case here. Here. Yeah. Because what we'll do internally is just convert it into a, like inside the function, we'll convert it into a float. And then the user doesn't have to worry about doing that themselves. So the radians here, node float. We're not going to negate it here. We're going to assume that you've negated it outside this function, or before you pass it in as an argument. So rotate by the radians, and then over here we multiply it by the pixel size, which we don't really need to pass in here because we've already got access to it inside this parent function. And then we need to divide by the screen size, and we're going to return that. So again, this gives us a number that we're going to use, vec2, so the x and y that we're going to use as a sample into the texture. Maybe we'll do that now. We're gonna do this part here. Before we do this, we're gonna do this part here. And I'm wondering, where did they do the, oh yeah, they do the conversion here. But before we do that, I think, you know what I think? My desk is in the corner of the room, and I've got a lot of stuff underneath of it, and I can feel how hot it is underneath the desk, where my feet's at. And it was cold this morning, so I've got a long sleeve on, but now it's warm. So I'm gonna go take this flannel off, and I'll be right back. So okay. So now we're gonna do this part here. And these are where, you're getting the center of that UV, but it's calculating it 4 times. One for the C channel, M channel, Y channel, and the K channel. And then they're storing that into variables. That's why we're doing it 4 times, because each of these, like plates or these channels or whatever, will have their own rotation. So doing it like that. So again, they've got these like hard coded in here at the top of the actual code right here. I'm going to allow the user to pass these in, as there's 4 of them, so it'll nicely fit into a vec4. So at the top of the function here, rather than taking in an angle, we'll take angles, and then the options here. This will be a vec4. And the way that you're intended to pass this in is as, I think you can do it like this. If you want to pass in vector 4, that's coming from 3JS. Yeah, so you can either pass in something that is already a vec4, or what we'll do is we'll convert this into a vec4 for you. So here we got the vec4. I'm just going to use their default numbers. Where are they? Here. So 15. And these are in degrees. So maybe we should say that the angles here are already converted. Because I don't want to have to do that math in the shader. So let's call these radians. Yeah, so radians, that tells you that you need to pass in radians. Okay, and then we've got this constant value that we can import from 3 WebGPU. I think it's degree. Oh yeah, let me just use it here. We'll do. Yeah, degree to rad. This is just a constant, so you multiply it with 15. Or what we can do here instead, this will be even better. 45,075 dot multiply scalar. Like that. It's kind of ugly, but that should work. And here we said this was, yeah, this is local, so you must pass it in like that. Okay, now we got our angles. So the angles are the radians. You don't have to pass those in because we'll just use these defaults here. But now we need to get these, so let's just copy this. And change this to const. Don't have a get, we just call it. Maybe makes sense to call this UV. Oops. And then we just defaulted to the screen UV. This is angles, or this is radians dot A or R. So the angle, the radians here, the first value is the C, this is Y, M, and K. But we can't do C here because there's no like accessor for C. But we can do X, we can do RGB Y, A, or no, sorry, we can do RGB A, we can do X, Y, Z, W, and then there's another one, it's like STU or something like that. But they're using, well, they're not using anything because they're passing them in one by one. So I'm just gonna do X, doesn't really matter. And this is W. Now where do they use the grid UV? Where did they use that? Oh, right here. But we need to convert this. Yeah, so here it expects more than one argument, and that's the UV. So before we do this, we need to actually convert these things to UV coordinates, or grid UV coordinates. And we can do that here. We'll say grid UVC. What do we pass in? The radians, that's going to be let's see, X, no, Z. Y. or CMYK. And this, we'll take these and we'll pass these in here. And the way that we know that is if you take a look at the name, it expects a grid UV here. What is this? Grid UVC, grid UVM, A, CMY, no Y, K. Okay, now, let me make sure that this is negated here, this radiance. Because this is the, like, rotate back part of it right here. So that's easy to do. You just take the radians, dot negate, and you can set that to a local variable. So grab this. Yeah, just like that. And I think so my thought here is that, you know, it doesn't matter if we call this XYZW, but typically those are for positions. And yeah, I mean, I guess you're rotating and you're dealing with the, like, UV, which is kind of like a position on the face or on the surface. I don't know. I don't know if I should call this RGB A or this, but it doesn't really matter. Yeah, so what if we just pass in, like, UVC here? Let's see what the output is. I don't see anything. Oh no. I think that's because we are not doing the subtractive part of it. Let's just keep going. These are all node vec2s, that's correct. But now we need to convert these to colors. But I'd expect that this would return something. Or I mean, just using it here would return something. Yeah. Just so that the notes match up. That looks good, that looks good. Oh, what's the matter here? Oh, maybe that's the problem. Yeah, does this help? No. What the heck? Okay. And let's try to use this. Okay, there we go. So this is, what is our rotation? 15? So you can see if we just use this is an interesting thingy. We haven't done the dot part of it yet, but we've done the pixelation part at least, and it's a rotated grid. So if we choose something that has more rotation, like the K, well, let's do the M, 45 degrees, and then bump this up to like 32. Yeah, so it's pixelated again, which is what we want. So now we're gonna use that sample. We haven't turned these into dots yet. But this is doing exactly what we want it to do so far. So let's convert these to CMYK colors. We're gonna need a function to do that. And this is kind of like not particular to this function here, this RGB to CMYK. You can see like we won't be able, like we won't have to, like this isn't either because everything is kind of, it doesn't refer to anything outside its scope, right? Well, I mean screen size and cells, screen size at least, but like I could move this out here, I believe. Or not. Okay, we'll leave it like it is. I'm just gonna... The argument I'm trying to make is that this RGB to CMYK is something that you can use in other parts of the project. So maybe eventually I'll move this helper function into like a library somewhere. If we ever need to make a shader or something that converts from RGB to CMYK, the halftone for sure, because you know it's emulating the printing colors, which use CMYK. So I'm going to call this RGB to CMYK. I'll take an RGB. I haven't heard this soundtrack in so long. I'm just remembering all the how many good songs are on it. Yeah, so RGB is uptied in Vec 3, yep. So the math behind this I haven't figured out myself, but you can find it here apparently on this dude's website, maybe in his GitHub somewhere. But let's just copy it. Actually, let's copy it like this. Well, I'm not going to copy it because I'm going to change. It'll be the same math, but it'll be written a lot differently. So the first thing we'll do, you can see that we calculate this K value, which is a minimum of every channel, or it's the minimum of the channels, but rather than just the channels, you take this 1 minus the channel. So we'll call this 1 minus RGB. Yep, and that's going to be RGB dot 1 minus. Now we need the K. That's going to be the minimum of RGB dot R. No, it's 1 minus dot R. Oh, hold on. 1 minus RGB dot R dot G dot B. So that's the K. The CMY part of it, don't have to pass 0 in there, it'll default to 0. I don't know why they call this invert K here. Because to me, inversion is like putting it 1 over that. Maybe they mean inverted by like, you know, in terms of colors or something. I'm gonna just call this 1 minus K. That's K dot 1 minus. Now we say if we can convert this to a boolean, actually we can call 2bool with it. If 1 minus K dot 2bool, we'll do something. We need to bring in this import and this one. We'll take the CMY.x. Well, we'll take the XYZ. So these we can all kind of do in one step. That's CMY.assign. We'll take the 1 minus RGB, and we'll do sub K dot div 1 minus K. And we'll return CMY. We'll return a vec4. That's CMY. Okay. Bring in all the imports that we're missing. Okay, that looks good. So again, while we want to have this have its own explicit return type, now we can take these colors. Or we can take the color that we get from sampling, turn them into CMYK. So taking the texture, I wonder if you could convert this whole texture itself into CMYK and then just index into that. Dang it. Leaning too far down in my chair, you can't see. I'm not centered. Yep, so let's just copy this. I think we can use this pretty easily. Or convert it pretty easily. Const. Here we'll replace. I wonder if there's a way to get what's under the cursor here. No. Can I do this? RGB2 CMYK. This we need to. This will be an easy one. We'll just take out 2D. We'll do input buffer. That's going to be text. Nice. Okay, we don't have this halftone dot function. So let's write that. That's the next step here. So that, again, we'll take in the grid UV. Because the first thing you do is convert it to grid UV, but we've already got that saved here, so we don't have to do that step. To make it apparent that you're supposed to do that, we'll call the parameter grid UV. That's a node vector 2. And here we should get out one color, one value. Not color, but we'll get out you know, value that ranges from 0 to 1 here. Okay, we got a grid UV. Now we take the fractional part of the grid UV. So that will go from 0 to 1. And then we want it to go from, at its minimum, minus a half to positive a half at its maximum. So we'll sub 0.5. And the reason we do this is because we're going to use it as input into this SDF function here. That gets passed to this guy. So I think I talked about that in last stream. But this SDF function here, you know, we want to make a circle out of this, or a dot. And the way that we want to do that is anything that's inside the dot is going to get colored. Anything that's outside the dot is going to be set to black, or whatever your, like, you know, whatever your outside color is. And the way that you do that is you just take the length of it, but this length is going to be from the center, or from 0, 0. So values on the left, you know, your negative values or whatever, kind of just need to shift the UV so that its top left, which is typically 0, 0, gets shifted so that its center now is at 0, 0. Which is what you're doing here. So fract will get it from 0 to 1. And sub will get it from minus a half to positive a half. That's going to be the distance to the center. Because our radius is just a half. I don't like calling this distance the center though, because it could be negative, and distance is never negative. So let's call this L, or I don't know what to call it. Oh, what do I call it in my notes? Where do I even call it? Oh, right here. Well, I didn't give it a name because what I did... We know that we're going to pass this into this length function. So we can just do .length here. Now we're here. And we're going to pass this value, whatever this is, into the interpolation function. So we'll return, and I've been using step, and this is the radius. We haven't passed that in yet, but that'll be a parameter at the top here. That'll be like the dot radius. But it'll be in UV, what's the word? It'll be like in UV space. So maybe we should do that first. Let's say we accept a radius. We'll let that be equal to 0.5. Now here, That's going to be float or node, or number, sorry. Oh, we don't call fract like this. We can just call fract on the end here. So step of radius, and then our value we're putting in here is this. But I think can I get away with this? Yeah. So I guess step you can just call like that, and they call it an edge. But the step works. If you don't know how step works, it's like if the value is below 0.5, it gets truncated to 0. Or 0.5 in this case. You know, if it's above your edge, then it gets, you know, set to 1. So any values below the edge are set to 0, any values above the edge are set to 1. And then the final thing here is to take 1 minus that. And why do you do this? Because we want values inside the radius to be set to 1, because we're going to use this as a multiplier in the end, right here. So multiplying by 1 just sets it to whatever the, like x times 1 is still x. Yeah, it's something to do with like, do I take 0 or do I take 1? So 1 minus 0 is 1, and then 1 minus 1 is 0. So flipping that number, like if you got 0 out here, but we want it to really be 1, we would just take 1 minus 0. And if we got 1 out here, but we wanted it to be 0, you would take 1 minus 1, and that'll be equal to 0. So that's just kind of flipping the output. Don't need this. Don't think I need that either. So take this. There. Don't have float. Const. Here we're passing in the grid UV, so UV replaced with grid UV. What's this angle thing? Did I take an angle? Take an angle here. Where are they using it? Oh. Yeah, we don't need to pass an angle here because we're passing in the grid UV already. So this we can just take out. Alright, sweet. We're almost there. So our output color will be white initially, and then we're going to, you know, this will be 1 on this side. We're going to multiply it or scale it down. So multiplying is scaling by some amount, and it'll be 1 minus whatever this dot thingy is. So what we can do, this can be cleaned up a bit too. Yeah, so what we'll do is we'll take a vec3, so we'll put these into a vec3, the C and Y parts. call that color. That'll be vec3 dot c dot m dot y. We'll take 1 minus that. That's this part. We don't have these strengths, but we can put those in later. So it's just kind of like scaling down or scaling up this value here. 1, like these are all set to 1 in this case, in our case. Where you can see that you can, like, if you had too much black in the image, you could scale that down by some amount here. But we have our color, and then we need to add in the like black part of it. So you'll multiply the whole thing. What they're doing here, you'll multiply that by your dot k dot 1 minus. And this will be our final color that we output. So we can actually just return it as a vec4. And then our alpha value is 1, so we want that to be totally opaque. What am I missing here? Oh, okay. Let's see. So we didn't pass in these here yet. You can see, like, in their version, that's their third argument. It's this coverage thingy. So what is this coverage? They talk about it at the top here. Where? Or maybe below. Yeah, right here. So it's a scalar on the dot size. So the dot size in our case is the radius, 0.5. You're multiplying it by, like, it's a scale of that radius. So if the color sample that you get out here is very cyan, this number will be kind of big. And that's the cyan part of the like cyan plate. Remember, there's 4 plates at play here. And they're doing some math on it, and they're multiplying that by the radius. So it's kind of like the radius is scaled by how much of that color you want to come through. Or should come through. I don't think that's the best name for this, but yeah, so we'll take the grade UV, and then this options. We won't do options here, we'll just say that the coverage is equal to 1. That coverage comes from whatever, and it can be float or a number. But what you need to do here is take the radius, multiply it by that coverage. So if it coverage is just 1, actually we can just inline this, dot mole coverage. I don't think, yeah, so this radius could be a number, but again, we're in this side of this function here. We'll just assume that the well, how did I do this? Let me go back to the notes again. Where's this radius come from? Oh, I see. Okay, this is interesting. You can just take the coverage. Where is it? So this mole takes either, do I have an example? Mole here. Yeah, vec2 or less or a number. So or number means that you can pass in a number here. So mole is already set up to take in float or number. Here we've already got float or number here, but we know that the coverage will be converted into a node of a float. So we'll let the user, no, we actually, it's kind of convoluted. What I'm trying to say is when we call this function here, this here is a node of float right here. Right here. So we know that the second argument that we're passing in is of a node. So the node, we can say that that's a node there. And if we don't pass it in, we'll just default to this. But we're only ever going to use this here, so you must pass it in. And then you can take the coverage, and we know that that's a node or a float, or that's a node of float. We'll multiply it. The mole here knows that it can take a float or number, so that's what we'll pass in the radius. So this doesn't default to 1, but we're just taking that coverage and just multiplying it by the radius here. This should be a number between 0 and 1 if we clamp it. We're not clamping it yet. Okay, what? F node. What am I missing here? Something's wrong. This. That's right here. I don't know why it's not liking that. Node float. Node float. What's the deal? Okay, let me just copy this. I know it's something silly, but oh. Ah, I know why. This grid UV thing is a function. Yeah. So we need to take the C and Y. Okay. And then here, this is also a function. Yeah. So we're almost there. I guess we are technically there, but it doesn't look very great, very good. And that's kind of because the dots are a little too big, maybe. But you can kind of see like your yellow is not rotated any. But you can kind of see the rotation of each of these like plates. There's not a whole lot of magenta in the image. But let's see what taking the square root of the coverage does. Now you can definitely tell like the black dots are larger. Maybe a little too large. You can take out the black dots right here. If you don't want them, you don't have to use them. And there is some kind of, like, you kind of see where the colors come together, and you get that subtractive thing going on. But I think to make this look even better, let's put that back in. We will provide ways to change the radius and the angles. We'll add more uniforms into this. Which, the way that we set this up, we can now just pass in uniforms into these things, into these parameters. So over here, oh, see, this should allow you to just call it like it is, right? You don't have to pass in a second, the options. Oh, I know why. This needs to be optional. So, options is optional. Yeah. So what can you control here? You can control the radius. Well, actually, I think the first thing we should be able to do is control the size of the dots. Where remember when we cut up the grid, you can control the pixel size. So we'll say size uniform 8. And we'll pass that in here. Size. So remember that, initially this was 32. Now it's being set to 8. And it already looks like more detail in there. I'm gonna make a folder for these. We'll call this uniforms. Our title is uniforms. And that's our uniforms folder. Now let's add some bindings to the folder. It'll be size, we'll set its value. So here I want the options. And I want these to be powers of 2, but I'm just gonna hard code them. Probably no smaller than 4, we'll do 8, this corresponds to 4, 6, or 8 corresponds to 8, and so on. So now we should be able to change the uniform value. Yeah. Okay, now let's do the radius. 0.5. And this will be kind of like spacing out the points as well, because the radius will be smaller. So, if you take 2 circles, and their radius here, if you decrease this radius, you're going to get something smaller and something smaller. This distance here should shrink because the circles are smaller. Like, they didn't change position, but now their circles are smaller. So kind of like the spacing between the circles will get modified. So maybe we'll call this spacing. And I want to change the name of that variable too, or that parameter too. Oh no, it's the radius, right? It's spacing. And then where does that come in? Right here. Let's add that to uniforms folder. That'll be spacing. Uniforms always have this value property. Here I want the minimum to be 0.1, maximum to be 0.5, steps of 0.1. Well, let's do, yeah, 0.1 is fine. Label, we'll call this spacing. Here the label all set as well. That's the size. Okay, so let's see what this does. Yeah. Okay, now let's add in the, what else? I think there's one more thing, and then maybe the strength is last. Options here, you can pass in the radians. So it'll be hard. Like if you're ever designing or like taking input, you probably want to take the input as degrees, because you imagine if you had to have a slider here that was like the radians. You know, your radians are usually like some long decimal number, or it has a long decimal part to the number. And you know, it's kind of hard to think about rotations in terms of radians unless you use radians a lot. To the average person, I know everybody knows what 90 degrees is and 45 degrees and all that. So here I'm going to do it like this. We'll take a new vector 4, and this will be, this is degrees, so we don't have to modify it, but we'll take the 15, we'll just take these values. Put them in here. And then we'll have this radians. That'll be degrees dot multiply with, this needs to be the conversion from degrees to radians. So degrees will be on the numerator. So if you have something in terms of radians, degrees, let's say this is like 47 degrees. To convert that into radians, you have degrees on the top, you need to multiply by some ratio. And that ratio is pi on 180. So the degrees will cancel out and you'll be left with some radians. We know that there's 180 degrees in every pi. So you multiply by pi, but it's not math.pi because this is a node. And then you divide out by 180. Now we can pass the radians here. Into the options. Now everything should stay the same because we have the same angles. But now we can control these. So what we can do here is a loop. And now each of these corresponds to, like the first one is the cyan plate. The second one, so it's C, M, Y, K. So this is C here, M here, Y, and K. so let's make something that we can loop over. So we'll call this cyan, and that corresponds to the X key. Magenta corresponds to the Y key. Yellow, the Z key. And then last we got the black, and that's the W key. Now this will be the label. Yeah, label, and this will be the key. But you'll see in a moment. Yeah, so another thing I want to do is add a folder for these degrees. You can just do that with the uniforms folder, add folder, we'll call this degrees. Folder title here is degrees. So here, we'll add a binding for each of these. Add binding. And we'll take in the uniforms. Or no, this is the degrees. This is going to be the key. And the options here. So this is, you know, from so no rotation is along the x-axis. And then because we're only, well, how do I explain this? I'm only going to allow you to rotate up to 90, and that's because every rotation beyond 90 is just a copy of some rotation already within 0 to 90. Because these are symmetric, these grids, along the x and the y or whatever. So you can imagine a rotation of 180 is just the same as a rotation of nothing. So a rotation of 135 is just going to be the same as a rotation of 45. So maximum of 90, step of 1, and then we'll just pass in the label. But it doesn't like this key, because when you do arrays like this, the type of this thing, the type of key here is just string, because it doesn't know any better. It's just going to take the like most generic type here. But you can do as const here, and now it'll be a read only, or it'll be like one of these properties, X, Y, Z, and W. So if I were to add something else in here, it'll get added to that union. So if I add like whatever, now this is X, Y, Z, W, or whatever. The other thing you can do is say that this is a tuple here. So this is a tuple, and then the second thing in the tuple must be of some union type. So you could call this something like T, and that has a type of string or X, Y, Z, W. And now if I do like this and I say this is whatever, here it has to be one of these types. If I try to pass in like something here, oops. Yeah, it's assignable to type. Oh, this needs to be bars. Yeah. So the way that you do unions is with bars, and now it should have the correct error type. So you could say that this is an array of this type here. Or just setting it to const is good enough. That's what I'm going to do, it's just set it to const. TP error. Some tweak plane parameter. Oh, this needs to be degrees out value? I don't remember. Well, apparently yes. So value will give you back. I keep jumping around. Yeah. Value here will give you the actual vec4, which you can modify. If you just did degrees, this is the actual uniform. It doesn't have a it doesn't have a value or a key. Like, it doesn't have an X, Y, Z or whatever. But the value, which is the vec4, does. Yeah, so now we should be able to rotate these grids. And it doesn't work. Something's not bound properly. Oh wait, is it working? Maybe it is. Let's do the black. Yeah, okay, it is working. Yeah, you can kind of see that. The yellow is very hard to see, but it is rotating. Rotate the camera. Let me make sure I got this coverage calculation right. Which is here, coverage, square root, or clamp the coverage. I think I should clamp the coverage before I take the square root. Am I doing that? No. So this is backwards here. I don't know if that's any better. But you can see, like, there's a lot of black coming through. And if we take this, like .05, yeah, you can control how much of that black comes through. And this looks a lot more like this here. Dark in my room, or in the living room. I have the windows closed today. It's kind of like a cloudy day. It was raining a lot last night. I don't know if it's supposed to rain again anytime today or tomorrow, but still got some cloudy weather. And this is the way that they're applying the strength. Yeah, I mean, let's do that too. Let's have some strength. This will be easy to do. So here's where our options are. We'll say, because this is nice that there's only 4 values here. So a lot of these things will fit into a vec4 like this. But let's just copy this and we'll do strengths. So this is going to assume that these numbers are normalized, or they're normalized from 0 to 1. And, you know, to make that clear, that'll probably be something in the docs. You know, strengths, you know, you'd say that strengths is expected to be a number between 0 and 1, and that's because it's being used as a scalar multiplier. Let's just do 1, 1, 1, 1. Now here we can just do .mul strengths.rgb, and here we can do strengths.w. I thought I could multiply like this, but I guess not. You can only multiply by a node color. That's interesting. I guess when you do .rgb, it says it's a color. Which makes me wonder if anywhere I'm using vec3 I should use color, but I don't think I see it anywhere. But you would take this. Strengths dot R. B. Let's see, that's a float, right? Yeah, what's it up saying here? Oh, strengths could be a vector 4. I need to do dot x, y, z. Yeah. So if it knows that x is a property of both node and vec4, but r is not. So if you go here and you look up vec4, it doesn't have .r property, which that is unfortunate. If you did color, I think it would work. No, it wouldn't, because it's a CMYK, and then the 3JS colors are just like RGB colors. There's only the RGB. I don't even know if it implements those getters. Oh, I guess it does. But can you? I'm curious if you can do this. Vec3. Okay, you can. So this is 0 here, which means we could probably just do strengths dot this, and then we don't have to do this here. Okay, and then make sure this works. Let's that just the 0.5? Yeah, I think so. If you didn't want like any of the blue coming through, CMY, that's here. Now you can kind of control like these plates, you can control them independently. You could say I want no blue. And then the very last thing I'll do. What's up? Almost done. You know, this is what we made here. This is already a post-processing thing you can tap into, but it's nice to do it yourself and understand it. But this is something that is already offered by 3JS, this halftone thing. But yeah, we made this. Here's the original scene. Oh, I got rid of the enabled. Didn't I? Yeah. Uniforms. Yeah, let me add this real quick. Yeah, here's the original scene, and here's the halftone scene, and then all these like things are parameters or uniforms you can control. What we're doing now. Oh, I think I'd like it. I'm so used to writing it in just like the code though. And I've been watching a little bit of Unity tutorials and stuff, and I'm like, man, it just gives you so much out of the box. I'd have to learn the language. Like, it's a different terminology for a lot of the same stuff, so I'd have to learn that. Like, they use terms like diffuse, and they use terms like albedo, and these are things that I've heard of, but you don't really see those terms a lot in 3JS. Yeah. So it would just be like, what was that again? You know, I'd have to be like, what was albedo again? You know, that kind of thing. But I did see this cool video last night. Let me see if it's still in my YouTube history. It was about creating anime shaders. I watch so much YouTube, I gotta go through and find where that video is at. You know, one thing I want to do one day is make, like, well, I'll talk about it in a second. Oh my gosh, so many videos. Oh, I lost it, but, it was like some more cool shading effects and stuff. Best looking world? What does the best looking world look like? I know what mine looks like. Oh, maybe I should take off that. Rivers of orange soda, yeah, you got it. That'd be nice. Yeah, what was I doing? Oh, yeah, this video was about, have you heard of this guy called, like, Mobius or something? This artist he's like a French artist. He used to do like comics and stuff, but he has a very distinctive style for his comics, and it's like these flat. Yeah, here's a good one. Well, yeah, it looks almost toon shaded, but it was a video about like recreating this, and I kind of want to do that next. But he did it in Unity, I believe. And here's a good example here. Like making a shader that does this would be pretty cool. And then I don't want to spoil it, but there's some interesting techniques involved. But there's also a game or something that looks like this. Oh, do you have a game like that? Oh, it says I can't. It won't load. Isn't that the URL? Oh. Let's see. I forgot to update links. Oh. Oh, that's a lot. I only pay for oh, .is. Yeah, .is has a lot more. I got a .dev domain and it's only $12 a year. What was it? /game. Uh-oh. I can't load your resources. Hard reload? How do I do that? Oh, oops. Ah, okay, here we go. This is hard to do on this keyboard. Am I safe to go down there? Oh, the borders? Yeah, these things? Oh, I made it. What is this? Oh, look at that. Oh, okay, I could traverse that. This is easy. This game's too easy. What do I do here? Oh. Oh no. Level 1. Mm-hmm. How many levels are there? Oh crap. 8. Do they get harder as you go on? No crap. Do I get a free life every time I do this? Looks like it. I can't jump right there. Oh, this is hard right here. Okay. Oh man, I'm speed running this. Okay, why can't it? Okay. Oh, he jumps so high. Does it have like short hops? No. You got a red line here. Did you see that? That might be for artistic effect. Jump on the last? Oh. Color bleed. Okay. Oh, it's so hard to do it because I have to use these 2 fingers to do it. That's because my keyboard is kind of weird. I have like a really small keyboard. Oops. Yeah, it's a Corn 36 key, but I have a really weird mapping on it. Yeah. It's it doesn't have any like, you can't, like, it's totally blank too, because you know you never really look at your keys, so why have letters on them? Yeah. I think I've seen this. Oh, this is the emoticon or whatever for Ghost, isn't it? The Unicode character for Ghost. Yeah. I want to show you that video that I saw. Maybe I'll just search for it. But I think it would be something you're interested in. It was a pretty recent video. Yeah, here it is. Yeah, I watched this last night and it was like, oh, this is pretty neat. Like, it's kind of annoying to do everything in GLSL. It would be nice to have a node graph or whatever, and like they do in Unity for doing shader work. I don't know. I might learn it one day. Yeah, I was really impressed. Like, I kind of want to go and look at those. Just get it right now. I'm almost about to end the stream though, but I don't know if I've got it. I might already have it. No, I don't. I might do a stream on like learning Unity. But that video or whatever talks about that's the latest version. It's free, isn't it? Yeah. Yeah, that's crazy. Like, talk about like very important software, like one of the most important pieces of software out there, and it's free. I'm like, you know, it's good that, you know, anybody can get into it. I hope one day like it doesn't get bought up by, you know, corporate whatever, and then, you know, you have to pay for it. That would suck. I mean, there are game engines out there that you do have to pay for. Yeah, it probably has controversy around it about other things, I would assume. Oh yeah, was that recently? Probably like a few years ago or something. I think I remember hearing about that. Yeah, you can't do that. That would be like cause for a riot or whatever. Yeah. Before I end the stream though, I want to get in these strengths. And then I'll close it out. Creating uniforms is trivial. Yeah, I've seen like there's like a panel on the side here and you can just like do everything in the panel. So it's a much more friendly like user interface, right? Yeah. Well, you can still get into like the actual code if you need to do something very specialized. Like you can still write shaders by hand. Based on neighbors. Is that like pixel neighbors, or I guess you could define like, you know, what neighbors are. I think there was one thing that really interested me was geometry nodes or something like that, which is a recently added feature. And you could just create, like, you know, you had some mesh or something that you could just turn into Legos like that. Yeah, yeah, that was really cool. That would be probably the first thing I'd want to get into. But I don't know if that's like an advanced topic or not. Oh, okay. See, that's crazy. Like, you just, hey, here's geometry shaders. Here's how you use them. You know, or geometry nodes or whatever. Here's how you use them. Learning the base part of it. Yeah, I feel like the learning curve is pretty high, but having like experience in 3JS and shaders and all that would probably be like, oh, this is like, oh, you know, I know exactly what this is. And 3D tile maps. Oh, that's interesting. So yeah, usually tile map is just like a 2D flat sheet or whatever, right? So I guess this is for like applying a texture to rounded objects. Yeah, in that video they talk about using because you can get away with, I don't know if this article goes into it, but um like the sampling a texture and using it, it's like using um your texture for like line art and stuff. But you know, usually your texture is anti-aliased or whatever. But you can get around that if you just use straight lines, which is pretty neat. I got it on the other monitor here. Build 3D tile map with, oh, 230. $250. So yeah, you can paint. Yeah, I saw that you can paint with your tile set in like 3D, but it's not just like extruding it. It's actually you know, applies texturing and stuff. It looks like, I don't know if this is a flat face here. Um, well, yeah, and it knows how to you know, merge these things together. It looks like. This looks like Animal Crossing a little bit. Second tile map for the second layer. Yeah, this is just like, you know, this is where you would put your body of water. And then, you know, I don't know if you played Animal Crossing, but they wrap this around a cylinder. And then as you're walking around town or whatever, you're kind of just walking around that big giant cylinder. And that's how you can create, I don't know if it's like a curved cylinder a little bit, but that's how you can create that sense of like, it looks like it's, you know, flat or whatever, but you have this like depth to it almost. Yeah. Every time I watch a video like this, I feel like I can take control of the scene, but it's not. It's a video. So I want to like rotate the camera upward, but I can't. This is pretty neat. Yeah. Um, what was I gonna do? Oh, is this yours? Your 3D world? Or your 3D tile set? Oh, this is, yeah, this is Blender here. Okay. Not reloading for assets, that's nice. Oops, oh, I'm watching the video. Yeah, imagine like, you know, once you have the kind of like vanilla asset, then you would just do everything either at runtime, or if you know that like, got this asset but I want to modify it based on like some game logic or whatever, then you could do that, you know, before you build the actual game, or at runtime. Yeah, I would be curious to see like people's workflow if they, because I know that if you're making a game, you need assets, and usually you do that in Blender, right? That's what it's designed for, or made for, not for designing games. But you know, okay, I got my asset ready. Now I need to add it to the game. What more do you do to the asset after that? Oh, I was looking for this song earlier. This is my favorite song out of Persona 5. What was the name of it? New Beginning, okay. Isn't that right? Yeah, New Beginning. Let me look at this. Remap materials, colliders. Blob map. Blobby. Yeah, you're right. The mesh or whatever, the model doesn't have any kind of physical like data associated with it. You know, if you needed to create colliding like collision objects and stuff like that. You see that in 3JS too. Like you have to import a separate physics library to do all that. Nav mesh? That sounds interesting. Yeah, because I'm thinking that that texture, you don't know, like the computer doesn't know what, let me see if I can draw this. Like if I had a piece like this, it doesn't know what it can connect to on this side. So you probably have to have something built into the texture maybe, or a separate, you know. Oh, this GK Johnson dude is pretty popular in the 3JS space. Basic character movement, yeah. Yeah, they use capsules for characters. Most, from what I've realized, or more from what I've seen. Yeah. Yeah, but I guess like that texture map or whatever you were showing, you don't know what can be connected on this side. Because you might have something in the texture like this, or, you know, just straight or something. So you need some kind of separate structure or whatever to tell you, like, this maps to this, you know. Yeah, I think I'm gonna do the strengths off stream, so I will do that. And then I'll upload this sometime later today if anybody wants to play around with it. Um, kind of the anticlimactic thing, but you can do halftone shading in 3JS already. Like this is already built in. I think it's an add-on. Oh, okay, right here. Oh, that's cool. It'd be cool to see if you could like generate this stuff. Oh. If you could generate this stuff, like as you walked out here, it would get generated in real time or something. That'd be cool. Yeah. Yeah, I'm sure you could do that. Imagine like totally generated worlds and stuff, or like randomized, uh, or pseudo randomized or something. Worlds that you can walk through and stuff like that. I wonder how big this rule set is. Probably not terribly big because 47 rules? That's not too bad. But I wonder, did you have to like code that all by hand or go in there and do it all by hand, or was there some kind of uh 15 to 16? Oh, okay. Yeah, I think this halftone thing is in, let's see. Oh. Yeah, so this just lets you like click and more like a GUI interface or something for doing this. It probably didn't just outputs like the, I don't know if it's like JSON or something that tells it what's connected to where or what can be connected where. Let me look for halftone. I don't know, I know this is somewhere in the code. I think I've seen it before. Yeah, it probably can be well, I don't know, a bitmap? Like a bitmap image? I was thinking like you probably don't need a whole JSON object or whatever. You can probably squeeze it into a very small structure. Oh, a map of bits. Okay, I see. Yeah, that's what I was thinking too. Um, you know, maybe you've got, let's say like a really basic example, left, right, top, and bottom, and then it's integers for each side, and then you just look and see, is my bit, you know, my index into that number or whatever, am I a 1 or a 0, and that means I can be mapped to on that side, or something like that. Okay, this is a halftone pass. Yeah, so if anybody's watching and they think they have to do this by hand, you do not. 3JS gives you a halftone pass out of the box, and I think they have an example of it, which has a lot more controls and a lot more inputs and stuff, which is pretty neat. This is actually varying here. Just, you know, this is a lot to look at. Like, oh, they have two shaders here, two halftones, but it's almost like too much that you can pass in, you know. Like some of these, I don't even know what this is changing. And I get they want to be generic. They want to provide, you know, as much functionality as they can. But sometimes you just have too many inputs. Almost like, hear about information overload or whatever. It's almost like that. Yeah, it does look pretty neat. I'll give them that. This model here, I was trying to find it, and apparently it's a 3JS, like it's part of the source code or something. It's not, you know, something that they've, it's something that somebody on the team created, and now they just use it in their demos. But it's got, like, if you look at some of the other demos here, like it's got animations on it too. So I was thinking about using this for stuff moving forward, but I don't know how I would have to attribute it and stuff. I think I've seen some of them in here. Yeah, some of these you mean? Like this one or whatever, I believe is one that a lot of people have seen. Oh, I've seen this too. This is like if you ever do look up how to do something in 3JS, you might see this dude's name come up in the forums and stuff. But I gotta say, like, I don't know if this website is very easy to navigate. Or I guess it is, but it's not a very pretty website. But yeah. I guess it's just a giant collection of examples from the community. Oh, and I guess you can download the source code too. I've seen these names as well come up. So this is all probably just a bunch of the people that you see every now and then, just getting together and sharing all their ideas and stuff. Models. Oh, not much here. So I'm gonna end the stream now, but I'll add in the strength modifier thingy. In next stream, I kind of want to go over this part of the blog post, which tells you how to get these shapes that look like they're overlapping, and you can kind of have like a gooey effect. Gooey as in like GOOEY, and you can create shaders like this. And you can imagine like that's kind of simulating what would happen with the ink. Like maybe the ink bleeds through a little bit, and you get this kind of thing. You know, if you imagine two circles or whatever that are at the center, and then there's too much ink in the machine or something, and then they bled through and they created that like peanut shape you see here. And then that's the end of the article. I'm not gonna go into this like control, like what is this? Let this thing load here. But in this example, you can kind of like control these dots and move them around, and then after a while they go back to their initial position. You can do stuff like that, but I'm not gonna get into it. The final thing will be this example here, probably. Oh, not this one. This one here. Oh, I'm just ending the stream. But I will stream again. What's today? Tuesday? Thursday. So tomorrow I'll prepare something and then stream it on Thursday. Here's what we made today, which is pretty nice, but maybe a little noisy. So I'm just gonna leave it like this for now. And it's something. Yep. Oh my gosh, a cat had a hairball. My mom's cats, she has 3 of them or whatever. So when I was living with her, there was hair everywhere. And one cat was like very nervous all the time. But every morning, that would be like the alarm, as you would hear him like hacking up a hairball, and it's like, okay, time to wake up. And this is around like 7 o'clock or something. So, and I think this will look a lot better when we control, like, this has so much black in it. but if you tone down the amount of black that you put through. But yeah, I'll upload this later today if anybody wants to play around with it. Here's the GitHub. Dang it. Here's the GitHub. No problem. Thanks for coming by and showing me all your stuff. But I can't say if I will get into Unity or not. Maybe. We'll see. I kind of like doing these 3JS projects and stuff, but I might get bored of them eventually. But you know, Unity would be such a good skill to have if I ever wanted to like get into some kind of video game development or something, right? I don't know. Anyway, everybody take care, and I will see you on Thursday. Just try it. Maybe I'll try it later today if I get bored or something. I got some sumo to watch, so nobody really knows this, but I'm a pretty big sumo fan, and there's some recaps I gotta catch up on. So I'll be watching that, but they're not long. It's probably be like an hour most. So anyway, everybody have a good day, and I'll see you later.